In this video, we're going to look at the example given in the manual. Okay, example 1. Consider the road AB shown in the diagram. Find the moment about A. So if let's say moment about A is you can assume that the nut or the pivot is at A. Okay, of the force of 5 Newton when it applied at each of the point B, C, and A. Okay, so uh, the question gave you in 3 situations. Okay, first, the force is applied at point B. So you remember that the moment formula is the force times the perpendicular distance. Okay, so the force is 5 and then the distance is 3. So 5 times with 3. But moment is a force. So if let's say it is a force, then you must have both the magnitude and also the direction. Okay. How do you find the magnitude? Is by using the formula force times with the distance. But how do you determine the direction? Is either clockwise or anti-clockwise. So if let's say clockwise, it should be in the mengikut arah jam, and anti-clockwise is lawan arah jam. Okay, so if let's say 5 times 3, okay, you get 15. And then how do you get anti-clockwise? Okay, if let's say this is a nut, okay, nut. If let's say you press it down, then your nut will go anti-clockwise. Okay? So it will become anti-clockwise. Okay. If let's say it is applied at B, okay, if let's say the force is applied at C, also the same formula, force times with the distance is only 2. And it is anti-clockwise because if let's say you have a road here, you push it down, then it will become anti-clockwise. It will turn around for clockwise, anti-clockwise. Okay, and then if let's say at A, so it means that you press it here. So if let's say there is a nut here, it won't turn anti-clockwise or clockwise, right? Okay, so because the distance is 0, so the moment is 0. Okay, now we move to the second example. Okay, in the diagram, find the moment of the force at C. So the force is at C about each of the point A, B, and C. Okay, this means that the moment will be at A, at B, and at C. So how will you represent a moment? You can use this symbol. For example, like question number 1 just now. The moment about A, you can just represent with A and then with an arrow like this. Okay, so for this question, it means that the pivot or the nut is at A and then at B and also at C. Okay, if let's say the force is 3, the distance is 4 plus 2, so you get 6. So you get 18 Newton meter. And how you determine the direction is if let's say you pull this down, this nut will turn like this. Okay, so it will turn clockwise. So it is clockwise. Okay, and then if let's say the moment at B, so if let's say the moment at B, it means that the nut is here. Okay, so the force is 3, distance is 2, so you get 6 Newton meter. And if let's say you pull this down, so the nut will go clockwise. Okay, and then if let's say the force is at C, and also the moment at C, so there is no distance, so there is no turning effect. So if let's say no turning effect, that means that it has no moment. Okay, example 3. Three forces acting on a body has a moment of 50 Newton meter clockwise, 10 Newton meter anti-clockwise, and 13 Newton meter clockwise about the point X. Okay, find the sum of the moment in magnitude and direction. So if let's say it is a sum, then it means that you add all the moments together. But if you can see that we have clockwise, this one is anti-clockwise, and another one is clockwise. So you need to make it all in clockwise. Or if let's say you like to use anti-clockwise, then you need to make it all in anti-clockwise. Okay, for example, here in this example, the solution here use clockwise. So it is easy. If let's say clockwise, then you put a positive. If let's say it is a negative anti-clockwise, then put a negative. So you get positive 15 minus 10, and then this is also clockwise, so plus 13 clockwise. So your answer would be in a clockwise. And you just add this all three together, so you get 18 Newton meter. Okay, example 4. A road AB is free to rotate about an axis through the point O. So if let's say you have a point O here, perpendicular to the plane on which the road rests. Forces of P and Q newtons as below. Find the combined returning effect. So you have more than one moment about the point O of this force. You have combined force, not combined moment. Here, so if let's say you have 2 points, okay, we do for P first. Okay, P is 6. So if let's say we have 6, distance is 2, so we get 12 Newton meter. And then now we need to check it, is it clockwise or anti-clockwise. So if let's say you push the rod here, so the nut will go anti-clockwise. Right, anti-clockwise. Okay, and then we look at Q. Okay, Q, the force is 5, distance is 4, so you get 20 Newton meter. And then how about the distance, the rotation? Okay, so if let's say you push here, so you're not here. So if let's say you push here, so it will become clockwise. Okay, now if you want to add this together, you need to make the direction same. So if let's say we're going to use clockwise, so this one would be negative 12 and this one would be 12. So 20 minus 12, you get 8 Newton meter, and then the direction would be clockwise. And the same solution for B.